how do we do that? So first thing is they're asking for, I don't know if you can see all that right, and they want the, let me write it up here. I want the end behavior. So the end behavior means like if you multiplied it out, what would be the most powerful term, the term in the very front? So x squared times x, it would be x cubed. And then there would be other smaller power stuff. So that's all. That's what they mean by the end behavior. They mean the most powerful term. That's the one that dominates. That tells you in the end if the function is going to go up, up and away, or down. That's how you know, right? What it's going to do in the end, meaning way off to the right. As you plug in 10 and 100 and 1,000, way off to the right. Is it going up or is it going down? How do you know? Well, if it's positive in front of the most powerful term, it's going to go up. If it's negative in front of the most powerful term, it's going to go down. Because he's the most powerful. He will eventually win. It doesn't matter what other numbers are in front of the lower power term. Plug a big enough x in, and the highest power will dominate the lower power. So he'll win eventually in the end, off to the right. Okay, so the x-intercepts. X-intercepts, are you comfortable with that? That's another name for zeros. X-intercepts are zeros. They're one and the same thing. They mean where does the graph hit 0, right? So how do we find those? When we have x squared times x minus 3, we take this piece here and we say if x is 0, this piece here if x is 3. Right? Those are the things we could plug in. Am I confusing you there? I didn't really solve them. I'm just kind of looking at it and I'm saying, what could I plug in there that would make this piece 0? Well, 0. And what could I plug in there that would make this piece become 0? 3. So 0 and 3 are the numbers I could plug into these two x slots to make the whole function be 0, right? So 0 and 3, that's the x-intercepts. That means on the graph, at 0 and at 3, we'll have x-intercepts. The function will be at a height of 0 at 0 and 3. Right? Y will equal 0. Because if you make either one of these 0, since they're times, then the whole thing is 0 and y is 0. Good. And now what do you do with y-intercepts?
You just said x is 0.
Yeah, good. Remember that at intercepts, you always set the opposite letter to 0. Remember that from the exam we just took? That was on there. So if they ask you for a y-intercept, you plug in x0. If they ask you for an x-intercept, you plug in y0. Which is technically what I just did. X-intercept, I made y0. And I said, how can these guys equal 0? I didn't say it all that way, but that was effectively what I was doing. You know what I mean? Maybe I should have done that. Let me go back and show you. Say it that way. That's another way to say the same thing. In the equation, y equals x squared times x minus 3. When they ask me x-intercepts, I set y to 0. So I make the y 0, and then I just say, okay, solve that equation. Well, how do you solve that equation? How does this part be 0 or that part? Again, we already saw 0 and 3, right? So for x-intercepts, make y 0, and now for y-intercept, set x to 0. It's always opposite letter 0. Why? Why? Well, because at an intercept, that's what it means. Like at a y, if the graph goes through some kind of y-intercept up here, for example, that would be what point? Over 0, up, I don't know. At this y-intercept point, the x-coordinate would be 0, huh? That's just what it means to be an intercept. You guys with me on that? Does that make sense? Right? At a y-intercept, right, you're over 0. Your x-coordinate is 0. At a x-intercept, here, this one's an x-intercept. What's this coordinate? 3, 0. See, the y is 0. At this x-intercept point, the y is 0. Everybody see that? So the opposite letter just is 0, isn't it? So if they ask me for a y-intercept, I say, okay, make the x 0. Take this equation and make the x 0. So let me take the equation. X squared times x minus 3, and put in 0 there and 0 there. What am I going to get? 0 squared times 0 minus 3, which is just 0. 0 times anything is just 0, huh? So y is 0. That's why I put in the 0 answer there. For the y, which is really this point right here, isn't it? The origin, 0, 0, is both an x-intercept and a y-intercept. Right? It's hitting both axes right there, isn't it? That's both an x-intercept and a y-intercept. Good. Now we're going to do multiplicity. We did some of that yesterday, so same thing. Can I go to a fresh screen? You guys good with all that? X-intercepts, Y-intercepts. So let's do the multiplicity thing. In fact, actually, okay. So so remember how we made a little chart? Didn't we say zeros and multiplicity for each of those zeros? So what are the zeros? Again, we found 0 and 3 are the two things that'll make that function 0. They're the zeros. Now for each of those, what's the multiplicity? So this one is the 0 and this one is the 3. Yeah, so what's the multiplicity, which just means the power, doesn't it? It's just a fancy word for power, because your power means how many times you're multiplied, right? So the x squared means x times x multiplied twice, multiplicity 2. And the x minus 3, there's just one of those. Power is just 1 on that guy, so it's just multiplicity 1. Good there? Good so far? Is that making sense? Just the power on that term. So, and then what does that mean about, bouncing or passing through the x-axis? Remember that?
Even bounces.
Even bounces. Because even powers like x squared are positive on both sides. That's why the U-shape bounces up. Positive on both sides, right? And odd pass through, or what do they say, crosses? That's how they say it, crosses. So what that means is at 0 and at 3, graphically, at 0, it's going to bounce. So it's going to pass through here. It's going to bounce at 0. See how it passes through the 3 and bounces at the 0? Now, actually, it could go the other way. What I mean is, in the end, it could go down and then pass through and bounce and go like that. How do you know which one of those is right? It's all about the end, isn't it? If in the end it's going down, then kind of tracing backwards, it'll pass through here and bounce there. It only hits the x-axis at these 2 points, nowhere else. If the end is positive, then it'll pass through there, because I know that's a pass. I know this is a pass-through point, and this is a bouncer, right? So it's going to pass through there and bounce there if the end is positive. Which one is the end? We already did the end, didn't we? The end was positive x cubed, right? The most powerful term. Remember, the end behavior is the most powerful. It's positive, so it's up. So it's the purple one. It's not the red one, huh? Let me get rid of this. This one's wrong. So the end is positive, isn't it? So in the end, it's going up, up, and away, passes through the 3, bounces at the 0. That's generally what the graph looks like, huh? Does that make sense on that? See how we're finding that? Based on the end behavior being positive and passing through the 3 and bouncing at the 0. Now, with that information, you can tell which of these, without even using your graphing calculator, you can tell it's C. That's the only one that looks right, isn't it? That makes sense there. It's got to be C. I don't even need my graphing calculator because of this analytic information I have. But you can use your graphing calculator. In fact, you'll need to, because they're about to ask us some other questions. Good so far? Can I go to a fresh screen? Yes. Okay, so to find the turning points and all that kind of stuff, let's first identify. So here's the real graph, C. And this right here, and this right here, right there. Those are turning points. This is a TP. This is a TP. Those are turning points. The turning point just means you're going up, then you go down, or you're going down, then you go up, right? So those are the 2 turning points on the actual graph, and they're asking me for those coordinates. Well, this one is 0, 0. It's the origin. But look at the kind of dumb way they want you to enter the answer. That wasted hours of my life years ago when I first did this question, and so I don't want to waste hours of your life. They really do want 0.00. They say round to 2 decimal places, and they mean it. That's really dumb, but so I don't want to waste your time. So this is 4.1, part 2, question 1, part E. They want 0. Instead of just 0, 0, they want 0.00, comma 0.00. Okay, now, how do you find this other turning point? Well, just use your graphing calculator and find the minimum. You with me on that? This point right here is a min. It's a minimum. Remember how we learned to do that on the graphing calculator? Yeah, you go to second, calc, on the TI anyway, and then it wants left edge, right edge, and guess, yeah. left, right. You go left of it, hit enter. Go right of it, hit enter. Go on your guess, enter. The Casio does it even nicer. You can just hit the min button, bang, it just finds it. So have trouble with that, come see me. Even after class, be 1 minute, I can help you with that. So make sure you can do that. That's gonna still, it's not going away. We gotta be able to do that. So find that minimum. So once you find that minimum, that is the turning point. Mins and maxes are the turning points, aren't they? So that'll give you the, it's actually just 2, -4, but they want you to enter 2.00, -4.00. So follow, play their game. Stop me if you have questions. On to F, domain. Domain is left, remember on a picture, this is our picture again. Domain means left edge, right edge. So left edge, right edge, looking at the picture. Domain. So left edge, right edge. The left edge, now remember this graph, we're only seeing part of it, but it goes down and left forever and up and right forever. We're just seeing a small window, but it goes forever down and up and left and right. So therefore, what's his left edge? Negative infinity, right edge infinity. That's why I'm saying it. Same thing, range. Range is up, down, huh? Again, that's negative infinity because down forever, up forever. So those are just negative infinity, positive infinity. Okay, now, question G. Use the graph to determine where's the thing increasing and where's the thing decreasing. Where's the graph climbing? Where's the graph going down? Like if you're climbing on the mountain or something. So let's come on in here and see if we can find that. So looking at this graph, wouldn't you agree, if you're a little person here, climbing on the graph, in this part of the graph you're going up, and also this part of the graph. Those are the two increasing sections. As you go to the right, it's always as you go to the right, you're going up here, then down in the middle, then up again. So these are the two increasing pieces. So that's what they're saying down here. They're saying, where's it increasing? So, and what they want is an interval. It must be off the screen, but they say interval. Whenever they say interval, what does that mean? What kind of answers do they want? X on the left, comma X on the right. It's X with X. It's not X with Y, right? Interval always means X with X, left, right. So looking at that purple piece, which remember goes down and left forever. What's the left and what's the right for this purple piece? The left is negative infinity. The right is 0, isn't it? This goes from negative infinity to 0 in the middle. So negative infinity to 0. And then the green piece, this is 2, and it goes up and right forever to infinity, isn't it? So they want you to go comma, 2. Oh, actually they want the 0, 0 weird thing here. I forgot about that. They want that here too. They're real picky. They want you to go 2.00, comma infinity. And then also with the 0 here, they want 0.00. And there's a comma in between. So there's what they want for where the function, the intervals over which it's increasing. Increasing. Negative infinity to 0.00, comma, 2.00 to infinity. The purple and the green sections, it's increasing, going up as you go to the right. And the decreasing is the middle. So we'll do that. Decreasing. Let's put that over here. Decreasing. So again, left edge, right edge. So left edge is from 0.00 to 2.00. Right? Bless you. Right in there. From 0 to 2. Good? Good. I think that's everything, right? Am I missing anything? You guys that have done some of this? Did I leave anything out? I think that's all the parts. Yeah.
Here's a question. Why wouldn't it be brackets?
Yeah.
Increasing part?
I think it'd be fine either way.
Yeah.
I'm not going to push you on that in a test. I think that's dumb. They're real picky about the parentheses here. Technically, they're right. I just think it's super picky of them. Because what they're saying, the reason they would say, they are saying that it's not a bracket, for example, at 2. No, because bracket means right on the 2. Because they're saying right at 2. What are you doing right at 2? You're right there. You're at the very bottom. You're not going up or down. You're not increasing or decreasing. So technically, you're only decreasing as you approach 2, not right on 2. I think that's super picky. On a test, I wouldn't care. I'm not going to give you multiple choice with parentheses or brackets. Which one? I'm not going to do that. Good question. That all good then on that? I think that's all the parts of, all 12 parts. looks like. So, yeah. So we know all the questions they're going to ask. Let's start with the end behavior. Can you do that first off? So what's the end, which just means, end behavior always means, what's the most powerful term? Multiply that thing out. Most powerful term, yeah. X squared times x squared, positive x to the fifth. So it's going up, huh? It's positive. If the most powerful term is positive, it's going to go up in the end. Most powerful term negative, down in the end. That'll dictate what happens in the end, right? And to find that, you see what I'm doing, guys? I just take the most powerful times the most powerful times the most powerful. Because if you foiled it all out, those most powerful players, when they get together, will produce the most powerful term. Good on how to do that? Okay, that's the end behavior. Let's go now to the zeros. That's where this one has a little bit of trickery going on. So let's try that. So let's find the zeros, and for each of those, find the multiplicity. Let me give you, I think you get more out of it if I give you a chance first to see what you know and what you're not sure about, and then I'll jump in. So find the zeros and the multiplicity. Hey, I gave back the first exam yesterday. I know some people did great, some people not as great as they were hoping. I hope that's not discouraging. There's plenty of points left. Let me encourage you. There's a lot. You can get a super strong grade. You can pretty much achieve any grade at this point still. We have 3 exams left and the final. 100 points for all of those. So lots and lots of points left. So you can get whatever grade you can. And it's all about mastering that homework, huh? So, did I tell you Roberto put new hours up back there?
Yes.
Okay, so he's there to help, get the help. I told you that I used to always go to my teachers for help, right? They'd see me coming in the halls. And so get the help you need. Master all these little questions. They will be test questions. Okay, so what are the zeros? Let me help with this. So first off, you just go piece by piece, right? So let me take the first piece here. What's going to make that part become 0? Well, just 0. Yeah, just 0. And the multiplicity is 2. The multiplicity is just the power. Good so far? And now, what about this piece? 2. That one's just 2. 2. And the power is 1, so 0 multiplies 1. Good so far. That's the easy part. Now, the part I really wanted to help you with is this part.
It doesn't work.
Yeah, it's nothing.
Even if you use root 2, you still have to add it.
Yeah, good. Does everybody see that nothing's coming out of that? There's no zero. Why am I saying that? Well, think with me. Let me show you 2 different ways. I can show you formally and informally. Just think, informally. What could you ever plug in there that would make that part equal 0? That's what we're trying to do, right? Zeros mean that piece there. There's nothing, huh? Because it's plus. If that was minus 2, then we could plug in root 2. And root 2 squared would be 2, minus 2 would be 0. But it's not minus 2, it's plus. So anything you plug in squared is going to be positive. And then add to a positive number, it's not going to be 0, is it? It's impossible. There's no way to make that piece 0. Does everybody see that? So you can just skip it. If you look at that and see that, just skip it. It has no way to make anything 0. Now, that's informally. That's just kind of looking at it. That's probably best, though. But I'll show you formally. If you formally said, no, I'm gonna set just him equal to 0, you would see that there's no answers. Move that over. -2. What do you do now to solve for x? You got to put the root. When you put a roof on the house, up and down the ladder, is how I always tell my algebra students. You put a roof on the house, you got to go up and down the plus and minus. Anyway, this is root. What's a negative in a root mean? Imaginary, huh? Which means not real. Not real. It's not true. I have an imaginary PhD, which means I don't really have one, right? So it's not real. It's not real. So there's no more zeros there. So there's the form. But you don't have to do that. I don't care. I never care what work you do. I would hope more and more you could just look at that and go, no, No way that's going to happen. But what if, again, what if that was x squared minus 2? What would I do? I would factor that as x plus root 2, x minus root 2. And they would both be zeros with a multiplicity 1. Remember how to do that? If it was minus, you would factor it. X plus root 2, x minus root 2. There'd be 2 zeros with a multiplicity 1. Okay, so I think the rest is regular. Can I just skip from there then? The rest is pretty much normal. I think we'd be better using our time elsewhere. So if you did the graph at 0 and at 0 and at 2, 1, 2, at 0 and at 2, you'd have zeros. What's the end? The end is positive. It's up, so I can just trace it back now. In the end, it's going up in the end, right? You always kind of go up and then kind of trace it backwards from there because we know the end behavior is up right there, positive x to the 5th. So it's going up at the end. Trace it back. Now at the 2, is it going to bounce or is it going to pass through? 2 has a 1 multiplicity, which is odd. So what's it going to do at an odd power? Pass through. What do they say? They say crosses. It's going to cross through. I'll put a C for crosses through. And then it's going to come up here. We know it's going to hit here at 0. And then when it hits the 0, is it going to bounce or is it going to pass through that one?
Bounce.
Yeah, because this one's even power, it's going to bounce, or what do they say? Touch. It's going to touch and go back down. This is a bounce. It's a bouncer there. So that's generally what the graph looks like, right? And so then they're going to ask you all the same stuff, like find the turning point right there, which is a minimum on your graphing not a mix, but a minimum on your graphing calculator and all the rest, right? Then this is in going up, and this is going up. These are increasing parts. The middle is decreasing, blah, 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 blah. All the rest is the same, I think. That's okay? Questions on that one? So number 4, this is problem number 4, is all graphing calculator. So put that into your graphing calculator. Put it in for y1. Put that in for y1. It's graphing calculator. And just hit the graph button. They're just going to ask you a million questions about it. Like, where's it going up? Where's it going down? You got to find maximums. Let me help you with the zeros. Yeah, that's probably a good place I could help. Yeah, so type that in for y1. Let's find the zeros real quick. So to find the zeros, which is the, x-intercepts, those are 2 words for the same thing, synonymous. So to find the zeros, you've got to, on the TI anyway, hit second calc and zeros. And, do they give a window? Well, you can just look at the graphs. You can tell they're going -5 to +5, -12 to +12. Yeah, I would just look at what they're doing. Same thing on a multiple choice test. You'll be able to just see the window they've got, right? So yeah, so x, -5, +5, y, -12, +12. Type that in, get a picture. And in fact, this is B. I've already got the answer for you. It's this one, like right there. Now, how do we find the 0? See, it looks like there's a 0 right there, maybe around -4, but not quite. It looks like it's -3 point something. And then there's a 0 there and another one right there. There's 3 zeros, 3 places it hits 0, looks like. How do you find them? You do them one at a time. Hit second, calc zeros, and then you got to go left, right, guess for each of those, one at a time. So left, enter, that whole left, right, enter, right, enter, guess, enter, like that. You know what you could do that's actually easier? A little bit on the TI, little bit easier, is you could let y1 equal, the whole thing. I don't want to write it all out, the whole thing, and just let y2 be 0, because then y2 is this x-axis. This is y2, 0, and then just do second, calc, and intersect. It's a little easier because you don't have to go left, right, and all that. You just have to you just hit enter, because it'll go first curve, second curve. So for first curve, second curve, either way, you can do it either way. First curve, second curve, you just hit enter. You don't even have to move it. You don't have to do anything. And then guess, you do have to move near, and then hit enter. You have to move near one of the zeros and hit enter. So you can do it either way. Just let y1 be the whole thing and y2 be 0, which is the x-axis. And just say, look, tell me the intersection between the graph and the x-axis. That'll find zeros. Or you could use the actual 0 function, which is a little more work. It's actually easier to do the intersect thing with y2 being 0. Just a little quicker. So either way, you guys getting on that? You finding the answers? Anybody got them? What are the zeros there?
Negative 3.738.
Negative 3.7. That sounds about right to me. 7.3 or 7.7?
I got some.
7.7, because you have to round it, right? Are they looking
Oh,
for
is it round to 7.4? You mean? Is it 7.37?
I got 7.26. So 3.726.
So that would round to 7.3. Oh, is it 3? Oh, is it 3 places?
Sorry, what did I say? Sorry, I meant 3.
It was just 2 places? Okay. Yeah, so my 3.73, that's this one over here.
I don't know.
And then the other two? Ma'am, we got the other two?
0.09 and 0.86.
0.09 and 0.86.
Yeah.
So those should be the zeros. Guys able to get those on your graphing calculator?
Me too.
Have trouble with that grabbing? I mean, really, just 1 minute after class, I could help you with that. I'd be glad to do so.
8.
And I have office hours 12 to 1 after class. I can do more extensive help. So make sure you can find those zeros. The intersect's a little easier if you haven't tried that. Just make y2 0, hit intersect. You don't have to do left and right and all that. You just hit enter immediately. Just boom, boom, and then move near one and boom, and you get it a little quicker with intersect. Okay, the rest is the same. See, once you've got these points, then, increasing, decreasing, turning points. You got to find the max. This will be a max right here. So max, down here will be a min. And you know how to find the min, left edge, right edge, all that. It's all that same stuff. Find all those points, and then the max and the min are where where increasing becomes decreasing. Right? That's where it turns. That's a turning point, isn't it? So that defines where it increases. Increases here, decreases in the middle, increases again at the end. So that's where you'd find all that stuff. All right, I'm going to leave that one behind because the other ones are a little tricky. So number 5, 25x minus x cubed. Like that one. How? And that's y equals. So this one we do have to do a little bit by. It's not just graphing calculator. They want us. Notice how to factor it. Notice how it's not. It's not factored. Notice there's no parentheses, right? It's not like that. It's not factored. We got to factor it. You guys with me? Let me show you what I mean. Look back. This is what's hard a lot in math is to kind of recognize different forms. Look back. Here's the one we just did. Now that one wasn't factored either, but it was just ugly. And I'm not going to try to factor it. It's just all them weird decimals. It's just graphing calculator, right? But the one before, see how that was all factored with parentheses and everything? So, that's what you need. You need to have it in factored form to find the zeros. Are you seeing that pattern? So if it's not already factored, then it's either graphing calculator, it'll find them for you, or factor yourself. So if I want to do this one by hand, I must factor. Okay, so how do you factor this thing? What's in common? X. We good so far to there? Right, because if you multiply that x, it would go back, right? And now can I factor further? 5 minus x, 5 plus x. Can I just turn those around and put the x in the front like that? Is that okay?
Yeah.
No. Because there's a negative x.
Yeah, remember the order, this one's fine, he's got no problem, but the order of subtraction matters. Right, think about numbers. 7 minus 5 is not the same as 5 minus 7. One of them is 2 and one of them is negative 2. So you can't do that, huh? You can't switch the order of subtraction. The order of adding's fine, doesn't matter, but the order of subtraction cannot be switched. So don't do that. Just leave it as it is. Okay, so there it is all factored. So what are the zeros then? Let's try the zeros. What could you plug into this guy? Take a piece. Once you've got it factored, parentheses, and then just go piece by piece. What will make this piece here? What can I plug in there? Well, just 0, yeah. Okay, that's the first one. And what's his multiplicity?
1.
Yeah, just 1. He's just got a power, understood 1, visible 1 power, huh? What about this guy? What can I plug in there to make this piece 0? 5, huh? So, and what's his multiplicity? 1, again, understood 1 power. What about this one? What can I plug into that one there to make that piece 0? Negative 5, huh? And again, multiplicity 1. And away you go. Those are all passing through points, and, you can find all the rest. I think from there. Is that good? Number 6 is tricky. We definitely need to look at that one. You got that all down? This will be that I did in the last section. So I did it with the other class today, and I realized I did it a little bit wrong with you. Maybe I'll go back to it. I don't know if there's time. All right, maybe. Let's see. Let's do this one first. You know the one where we had to multiple choice and eliminate? There were like 6 options, A through F. I think I said there were like 3 options left, but there really weren't. I forgot to look at the pass-through bounce thing. That's what I think I forgot to do. Anyway, if we have time, maybe I'll go back. I don't know. We'll never have time. I won't. Yeah, let me just be straight. I'm not going to have time. Come see me, though. Be glad to talk about that. Come see me. I just forgot to do the bounce pass-through. Make sure you look at those homework questions. Really master them. I kept lists. Talk to my teacher. Please do that. Be glad to help. All right. This one's hard to factor. So let's factor. Because, again, it's not factored, right? No parentheses. Not factored. It's not factored, so we must factor. You either have to factor or use the quadratic form. I mean the calculator, right? So this one we can actually do by hand. It's not ugly decimals. We can do it by hand. So, but do you remember how do you factor? This is what F is Y. Y equals. How do you factor when you've got like 4 numbers?
Take out a 3 and an X.
Yeah. Oh yeah. First step, they all have 3 in common, don't they? I didn't even think about that. Good job. 3 and X. Good job. Yeah, I just did that one a harder way with the other group. That's right. 3 and X. Yeah, good job. Okay, and so then that would be X cubed. And that would be what? 7X squared. And that would be 9X. Yeah. And then that would be some big number I don't know.
63.
Is that it? Okay. 189. Yeah, good. All right, good so far? So take out the 3X. Good job on that. Now we're not done there. We can actually go a little further. The 4 terms that are in the parenthesis. Do you remember from algebra? This is pretty, I didn't remember when I finished algebra. It's pretty tricky. You can do like a first 2, last 2 thing. So just leave the 3X. You know, he's there. Don't worry about him. But these 2, what do they have in common? X squared. Okay, and then these 2, what do they have in common? Minus 9. Good to there. Good so far. I just did just the first 2, just the last 2. And oh, you caught up? You okay? And then, now, what do you do with these guys? Well, notice they again have a matching piece of parentheses X plus 7. That's right. In other words, it's like, if I can help, math is just patterns. So let me show you the pattern you're looking at more simply. That's the pattern. What if you had, you know, just this, don't let this big old X plus 7, just pretend it's a big old W. You know, what would you do with this? You would say, well, look, they both have a W. Take it out, right? That's exactly right. Look, they both have an X plus 7. Take it out. What is left? X squared minus 9. Good so far? Same thing as just taking out a common W. It's a common X plus 7. And then the one more step is this X squared plus 9, huh? That's X plus 3, X minus 3. And then we have it. So 3X, X plus 7, and then this piece is X plus 3, X minus 3, like that. Does that make sense? So there it is. It's completely factored at that point. And then the rest is, you know, normal. Find your zeros, find your increasing, decreasing, turning points, all that. Good. Tough factoring there. No questions. I'll leave.